Good morning, afternoon, evening, wherever you're joining me from. Today, we are going to do something different. Today, we are going to build a game with Lightning Web Components. My name is Aditya. I'm a developer evangelist here at Salesforce. And you can follow me on LinkedIn or Twitter and make sure to hit the bell icon so that you'll get notified about all of the awesome content that we roll out for you. Before we dive in the forward-looking statement, please make any of your purchasing decisions based on generally available products and not based on what I might say today. I mean, in terms of building a game, there is nothing much I can say except for the fact that maybe just like if you don't have internet on Chrome, you get to play the dinosaur game. Maybe if you don't have internet on Salesforce, you can play the snake game. I don't know. Maybe it's a good to have feature. So what are we going to do today? Of course, this is a code live session. So we are going to first build our game and then we are going to deploy our game. Now, why is deployment an important step today? It's primarily because one, you get to see how you can deploy this game onto Salesforce, Heroku, GitHub Pages. And moreover, once I deploy this game, you can start playing it right away. I mean, once the session is done, you can start playing the game. And whatever is the source code that I'm going to write today, I'm also going to open source it, which means you can make any changes to the game and then deploy it on your own or put in a pull request and then the live game gets updated. So that's pretty much what we are going to do today. So what is the inspiration behind a game? I mean, all along we have done a lot of sessions on Lightning Web Components, but never really built a game. So what is the inspiration? The inspiration is actually you people. The reason being the community, that is, you have built a lot of games already, which kind of piqued my interest. So it all started with the quiz app that Philip has built. That is something that we've been using quite a lot for the past 6 to 8 months as a replacement for Kahoot. Inspired from that, I built the Planning Poker app. More about that in the near future. And then when I look at Twitter, I see a lot of tweets around the chess game that has been built, and also book cricket. I think it is book cricket, and then rock, paper, scissors. So there are a lot of games that the community is building. So I thought, why not build one on my own? And I also saw this tweet which said, "That's really cool. Can you tell me which game I can implement as a beginner?" So I thought, why not do a session on building a game? So it'll be cool, it'll be fun. So that is why we are here today. And so what did I do? I mean, just like any other good developer does, I went onto Google and I typed in JavaScript snake game. The reason behind that was I've never built a game before, let alone on HTML. So I wanted to see how people really build it out there in the ecosystem. So I've looked at some of the versions. Most of them used HTML5 canvas, which was okay. I mean, it was working good, but it's not really interesting because you're only putting one canvas on the HTML and then writing a lot of JavaScript to manipulate the canvas. Not really something that a web component would do. I mean, it's basic. So I started searching for things which doesn't involve canvas. And then I came across a game built using Vue.js. The code was a little bit complicated, but I kind of got what they were trying to do. And that is sort of going to serve as an inspiration today. And the other inspiration is this one line in the documentation for Lightning Web Components, which really says, using JavaScript to manipulate the DOM isn't recommended because LWC does it more efficiently. So that is the whole reason, I mean, why we don't want to like manipulate JavaScript or put in a canvas and use JS to manipulate the canvas. So that's sort of the inspiration behind what are we going to do today, why are we building a game, what are we going to look at. So with that, actually, let's build. So before we get started, it is definitely helpful to visualize what we are building so that it becomes easier for us when we are trying to write code. So like I mentioned, I have looked at a couple of sources for inspiration, and the best approach for Lightning Web Components is to actually divide the entire available area into smaller blocks of divs. So here is how it's going to look like. So assume it to be kind of like an axis where this is our x-axis and this is our y-axis, and this is our entire game area. So what we are going to do is we are going to divide it into smaller blocks of divs. So let me draw these blocks. So this is how we are going to divide it. Now our x-axis is going to have these coordinates 0, 1, 2, 3, 4. And y-axis is also going to have 0, 1, 2, 3, 4. Now the way we are going to name our divs is based on the x comma y denotion. So x comma y is 0 comma 0, 1 comma 0, 2 comma 0, and so on. And if you go down the y-axis, it is going to become 0 comma 1, 0 comma 2, and so on. So this is how we are going to create a grid. And after that, what we are going to do is our snake is going to occupy a particular div. Now the way we'll do it is, so each div is of a color. So we are going to set each block to a background color of, let's say, green. Now whenever a snake comes to this position, we are going to change the background color of that particular div to, let's say, yellow in this case. So now the div is going to have a yellow background. And if it is a food that the snake eats to get longer, we are going to denote it, let's say, using a red color. So every div is going to be a position where our snake or food can be. So based on this position, we are going to color the div accordingly. And how we are going to make the snake move. So let's say the snake is currently in this position 0, 0. Now for the snake to start moving towards the right hand side, you'll notice that the x coordinate is getting incremented. So we move from 0 to 1, 1 to 2. If the snake is moving down, the y coordinate is incremented, 0 to 1 and 1 to 2. And of course, we've all played the game, so we know there is no diagonal movement of the snake. It's either left, right, top, down, which means at any given point in time, either you are incrementing the x coordinate or you are incrementing the y coordinate. So that is sort of the basis of building this game. Create a grid of div elements, then denote each of the div elements with a certain symbol x, y, and then emulate the snake by means that the color of the div keeps changing based on where the snake is present. And then the way you move the snake around is by changing the x and y positions of the snake. So that is the basic theory behind how the game is going to function. So I'm going to go ahead and quickly start creating the game. So what I've done here is, this is a standard SFDX project inside which I've created a new Lightning Web component called as game. And because I'm building something which is entirely on the client side, I don't need a lot of data. And to test this out, I don't want to keep deploying it to Salesforce often. I am actually going to use a local development server, which is going to automatically refresh whenever I make any changes. So let's get started by building the game. So the first thing I want to do is I want to define a header for the game, and which is going to show the score. Of course, no game is good without a score. And I also want to apply some styling. I mean, I have some idea in my mind on how this is going to look like, so I'm going to build it out. So I'm going to add a little bit of padding. I'm going to use the SLDS classes. VS Code is going to automatically suggest them. So P stands for padding, so I want a medium padding around that. And what you'll also notice is the suggestions that SLDS gives. So instead of using the standard P token, I can use the variable token, meaning that based on the density that you define in your org, it's going to modify the padding accordingly. So this is good, and then I wanted to align to the center, so SLDX text align center is good enough. Now next I want my game container. This is actually the place in which the game is going to be present. So now going and defining the classes for header. Let's give it a background. I generally tend to write some color so that VS Code, I can use the plugin to then select a nice color that I want. Again, personal preference. So I've given a background color, and I think that should be good enough. So the score, now the game container. So the game container is what is going to be the place where I create the grid. So copy paste always works so that I don't make mistakes. So now the game container, I want the width to be, let's say, 70%, and height is 60 VH. And then I want to give it a background color of, let's say, a lighter green color. Okay, I'll give it a little bit dark. Okay, so I have this, I have my game container, and inside the game container I have my smaller game blocks. And these game blocks, like I said, I can define another class, let's say game block, and inside my container of 70 by 60, my block should occupy a tiny space. And when I divided my canvas, my area, into a grid, each block is of the same size. So I want my game block to be of 20 pixels in width, height is 20 pixels, and then I'll give it a background color again. So it's easier if I start copy pasting stuff. I'll give it an even more lighter color because this denotes the area in which the snake can move, so it needs to be very clearly defined. So let's save this for now and see how it appears. Okay, I think this is a pretty good canvas. It's just that I need to make this white color. I don't like it to be black because of contrast and stuff. So this is my canvas 70 by 60, and then I have this game block, which is one single block of a different color, which is good. But now is the real problem. That is, I need to create this grid layout based on the width that is available to me, because the width and height is dynamic. So I need to calculate the number of blocks that are needed to fill my entire canvas. So for that, I'm going to use JavaScript, and first thing I'm going to do is make the score dynamic. So define the property score, and then I'm going to call renderedCallback. I'm using renderedCallback because I need to access the width and height of the container, and that can only be done inside renderedCallback. So I'm going to say let x width is this dot template.query selector, and I'm going to select the game container, so dot, and to get the width of a particular element you'll have to use client width, and of course I need to get the height, so okay, actually it doesn't matter, x width or whatever. We are calling this the element height, and it's going to be client height. So now theoretically I have gotten my width and height, and now I need to divide this into blocks of 20 pixels each. So let me define block size to be 20, and then let x max, the maximum number of blocks on the x axis, can be the e width by this dot block size. Similarly, let y max is equal to element height by this dot block size. Now one problem here is the width and the block size might not always be divisible completely, which is why we'll have to round this off to the lowest integer, for which we'll use math.floor. And then here I use math.floor. Now I have the number of blocks that have to be created on the x-axis and the number of blocks on the y-axis. So now to generate my grid, all I need to do is run 2 for loops. So let's say for let. Now how do I create these elements? So I need to create the elements this way. So it has to be 0, 0, 1, 0, 2, 0, 3, 0, which means to iterate on the x and y. For the first row, y is constant and x is incrementing. And then y increments by 1, and then x again runs for all of this duration. So x needs to be inside the for loop. So for let y is equal to 0, y less than y max, y plus plus, inside which I'm going to do for x is equal to 0, x less than x max, and x plus plus. So it's just a simple for loop that I'm running. And now for each of the iteration, I need to add a new block. I need to add a new game block. Now, one way I can do this is I can query for the game container using this dot query selector dot game container, and they can add a HTML element to it. But like I showed you in the slides, I don't really want to manipulate DOM using, I don't want to really manipulate the DOM using JavaScript. I need to find a way for LWC itself as an engine to modify the DOM based on certain properties that I define. So how do I explicitly not add elements to a game container, but have it generate these game blocks? So the best way I can do it is through placing this inside an iterable variable. So I can say template for each, and I define some variable, and I say then for item is block, and then for every block that I generate in the backend, I'm going to show the iterate this div so many number of times. So in a way, I'm not actually inserting stuff, I'm not calling the DOM manually, but the for each directive, the template is taking care of generating that for me. Now, one thing you'll realize is once you put in a for each loop, you're going to need to specify a key for each parent level item inside the for each. Now for that, what I'm going to do is, so I need to define a key. I need to iterate over something, and then the key has to be present. So I'll take inspiration from the object structure that we have. So I'll create an object with an ID, and this ID is going to be my x colon y. So like I said here, I need to be able to identify a particular element using these coordinates. So I say x colon y, for which I'm going to use this syntax x and y, and then I'll have to create an array of these objects. So let's say game blocks is equal to an empty array. Okay, and this dot game blocks dot push of object. Okay, so I am creating a game block and I'm iterating over X and Y and pushing the blocks. So let's save all of them and see what happens. So this automatically refreshes and it has to show me all of my elements. Okay, let's actually check if there are any errors first. Okay, unexpected token. Oh, of course. I didn't give this. And key is going to be block.id. Okay, let me just print that inside the div. That is one use of local development. I mean, rapid prototyping. Any mistakes that I make, I can see it right here. Okay. All right. So undefined reference error X is not defined. Okay. Let X. And we wait. I mean, this is a lot better than waiting for it to deploy. And refresh. Okay. Now, has it really created all of my elements? Okay, div score. Nope. Um, it hasn't created any of my elements. This is bad. Because, yep. I don't know if you have noticed, but I've used an array here and then I'm using array.push. And primarily all those properties are trackable by default, but only of primitive data types. Now here, since this is a non-primitive data type, I need to make it a track and then specify track in my import. And this hopefully is going to refresh my screen. Okay. Okay, there is one error. Duplicated key attribute for item number 170. A key with value 100 appears. That is strange. X less than X max, X plus plus. Okay, this seems to be going in an infinite loop, and I'll tell you the reason why. So this is one of the things I was mentioning, that performance is extremely important, and we have made one mistake here. So every time we are pushing an item to the game block, the UI is going to get re-rendered, which means the rendered callback is going to get called, which means this is happening over and over and over again, and it is running into all of these problems. So whenever you see such issues, know that you'll have to make sure whenever you're manipulating the DOM inside a for loop, you'll have to do it in a more elegant way. That is, instead of pushing all the elements inside a for loop, let's create a local array and actually push it to this local array, and then say this dot game blocks is equal to temp blocks. Now this is the first level. Now even though you do this, what happens once the game blocks gets assigned, all of your blocks are going to get rendered, which means the rendered callback is called again. Again, it's going to go through all of this logic, update the game blocks, and again. So I need a controlling variable. So I'll say render complete is false, and I'll say this dot render complete is true, and then place all of this inside a render complete. So I'll take all of this, and put it inside render complete. Okay, so now when I save it, of course this is stuck now. The local development server, it is running in an infinite loop. So let me reload it in a different tab. You see, closing this is also a problem, and already the system is slow and I'm taking up a lot of resources with this infinite loop. Okay, so this time hopefully the grid should get generated correctly and it should show me the output. If not, oh well, okay. The outputs are shown 0, 1, 1, 0, 2, 0. Yep. It's generated it correctly. So after 16, 0, it is again 0, 1, 1, 1, 2, 1, which is good. But one problem is everything came in one single line. I want it to come horizontally. So for which there is very simple fix. You just say display inline block. I think it is inline block. Okay. So that way it's going to come one beside the other. Okay, once the grid is generated, half our work is done. This looks perfect. So my grid is completely generated. It's a 16 by 12 rectangle based on the width, which is good. Now the first part of it is done. So I was able to generate the grid. Now the second part of it is to be able to put in a div with a different color to denote the snake. Now to do that, what I'm going to do is, of course, we are going to have to define a class name for the snake. So let me define those class names first. So let's say snake, background is green, and food, the food for the snake, background is red. So I've defined this. Now I need a way to identify which of these elements. So each object denotes my block. Now one of these objects can be a snake, one of these objects can be the food. So in order to denote which one is the snake and which one is the food, I'll say snake is false and food is false. Now I need the first element to be the snake, and the snake has to start somewhere, and I want to start it at 0, 0. So if I say if x is 0 and y is 0, then I need it to be the snake. So so if not, else. So this becomes true. If it is 0, 0, then snake is true. And then I'm pushing the object. And then here I put in a conditional statement. So template if true, block dot snake. Then I show it to be game block and snake. If it is false, it's just a game block. So this is one way of doing it. Okay, so let's save and look at the output. Okay, so 0, 0 is showing correctly. So now this is my snake. I have established the basic instance of my grid. I have put the snake. Now the next one is to make my snake move. Now the snake has to change its color. So that means from 0, 0, let's say it has to move to 1, 0, 2, 0, 3, 0. So now is where it gets interesting. Now if you look at a game, the game is always running continuously. So if you look at the snake game, the snake is always moving in whatever direction you ask it to move, which means the same logic is recurring over and over and over and over, which is why what we are going to do is we are going to use a set interval function for that, and we are going to run the snake, we are going to move the snake, let's say 4 times every second or 3 times every second. We are going to keep moving the snake. So that is what I'm going to do now. So let's say I'll define a method called start game, and here I'm going to use set interval, and VS Code is going to give me the syntax. So set interval, let's say 300 milliseconds. I want to move the snake. So now I need to define a function called move. And here is where most of the logic for our game is going to sit in. Now the way we need to move the snake, like I mentioned, is if it has to move in the right direction, the x coordinate has to be incremented by 1. If it has to move in the left, the x coordinate has to be decremented by 1. Same for the y-axis, +1, -1, +1, -1. So that's the logic we'll try. And based on my experience watching other YouTube videos on how this is done, I have a very good idea. I mean, it's a beautiful way of implementing it. So what they do is they define x speed and they define y speed, which we will also do. So the speed is going to define what is the increment number. So it can be 1 or -1, same 1, 0, -1. Y speed is 1, 0, -1. This is what is going to be the default value. Now to move the snake, I need to identify the current position of the snake. So the current position of the snake when the game starts is 0, 0. And the way I identify that is by creating the head of the snake. So I say x head, y head. It's also initialized to 0. Now to move the snake, all I need to do is I need to say this dot x head plus is equal to this dot x speed. So I'm incrementing head, the x-axis of the head by 1 or 0 or -1, and the same thing goes for the y head. So essentially the x and y coordinates of the head are moving based on the speed you specify, and here it is 1 always. Now internal to my JavaScript, I know that these coordinates have changed. But now how do I let the UI know that the coordinates have changed? It is by modifying my game blocks. So now my game blocks currently holds all of this information where snake is true for the first one and for all the others it is false. Now how do I make sure the snake moves 1 ahead is 0, 0, it should become, the snake should be false, and 1, 0, the snake should be true. So here, if the snake is moving from 0, 0 to 1, 0, this is no longer the snake. So we have to make this false and this one true. That is what we can do. So the moment it comes into the move function, we need to identify the position in which this particular object is present. So for that, find an object, and we'll find the index of an object inside JavaScript. Now I'll show you why we are doing this. We have to match a particular condition and stuff. Okay. Okay, so let current position index is this dot game blocks. So within the game blocks, I'm trying to find the array position of the current head. So the current head is going to be x.id, and it is going to be x head colon y head. So the find index function, essentially what it does, it looks at all of the elements inside this array. It executes this if statement. So wherever the ID of the object is equal to x head and y head, it returns the index of that particular element. Now, why do we need the index of that element? We need it because we are going to do this dot game blocks of current position index dot snake is equal to false. And then once I increment the head, I'm going to do the same thing. I'm going to find the new element and I'm going to call it new position index, and I'm going to say it is now true. So basically, this is the logic. Let's see if it is working or not. Okay, it's not moving at all. The reason being I haven't even called start game. My bad. So once the render blocks is complete, I'll call start game and let's see if it moves. Okay, X head is not defined. There are a lot of errors. Obviously, this is the most common mistake that I make. I forgot to give this. I mean, half of my time goes into forgetting this when defining properties. Hopefully I haven't forgotten it anywhere else. Okay. As you can see, the block is moving. And then after it has crossed the 16th block, there are multiple errors. So that is because we are not able to find an index. We are just incrementing x to from 0 to 16. Now it has become 17, but there is no 17th block, which means I need to limit it. And now how do I know how many blocks are present? I have the x max over here. And for me to use it inside this function, I need to make it global. So x max, y max, and then this dot x max, this dot y max, and of course here as well. Okay, so now we say after incrementing it, if this dot x head is greater than x max, so if it becomes 17, which is greater than the maximum of 16, then we say this dot x head is equal to 0. And yeah, this dot x max. Okay, now here is a choice that I've taken. I mean, if you cross the boundary, if you want the snake to die, of course you can call a different method here that ends the game. But for now, I want the snake to come out from the opposite end. I mean, in some snake games, the snake only dies when it eats itself. That is what we'll try to do. So we do this if x head is greater than x max. X head is equal to 0. And let me think this through. X head is 0, 1, 2, 3. Okay. We'll put an is equal to because the index starts at 0. So same thing let's do for x head is, what if we are decrementing it? So if x head is less than 0, then x head is this dot x max minus 1, because if it is total 17 blocks, the index of the last block is 16. The same thing we do with y. So if y head is greater than or equal to y max, y head is 0, y head is less than 0, then okay, so this should do it. Let's refresh. Okay, let it move, and yep, it's coming out from the other end. Now the next thing we need to do is we need to add controls. Now the snake is only moving in one direction. We want to move it in all the directions possible. So for that, okay, let us add keyboard controls. Now here what we are going to do is we need to listen to the up, down, left and right arrow mark. So we are going to use window.add event listener, and we are going to listen to the key press or the key down event. I think key down is better, and then define our arrow function. Okay, now it's going to have the event E. So let's see console dot Okay, first we'll e.prevent default and then console.log of e. Let's see what e prints. Oh, I need to call this method in my rendered callback. So I will add keyboard controls and then I'm going to call it. Okay, so if I'm clicking on the up or right or left, if you notice here, it's actually printing the key to be arrow up, arrow left, arrow right. So I need to make use of that. So the way I can do it is, so let me see how to use a switch case, JavaScript. Yeah, I mean, I Google a lot of stuff. It's easier. Okay, so the switch is going to be e dot, whatever that is, key. Okay, so now case is arrow up, okay, so now if I click the up arrow, what should happen? The snake should move up. So when it is moving up, what is happening is the x stays constant, but the y decreases by 1, which means we'll have to say this dot x speed, the x has to become 0, and this dot y speed becomes -1, and of course break. So again, 1 2 3, and we don't need a default. Okay, so arrow up and down, arrow left and right. So whenever you're moving down, again x is 0 but y becomes 1. When it is left, arrow left, x decreases, so it is -1, y is 0, it's 1 and 0. Okay, so now let's see. I've added the keyboard controls. Every time this runs, it should probably work. Okay, so let me click the down arrow. Yep, it is moving down. Now left, now up and right. So let's see if the right works. So now let's click on up. Oh, okay. So did you notice that, I mean, whenever I'm, let's say, going down, it is taking some time to come from the top and then it is incrementing very quickly. But that the same thing is not happening when I move from left to right. So that is a small performance issue. And the way I think we'll have to address that is, because every time we are iterating over this, there is a key that comes into each of these if-else blocks, and then there is an evaluation happening every time there is a re-render. I think that is why it's a little bit slow. So the other idea I have is, so instead of defining multiple if true and if false blocks because of duplicating the key or maybe reevaluating it all the time, I'm going to just define this at the top level, and then I'm going to modify the class of it dynamically. So that way, what I can do is I'll say this is block.class. Now what happens with this is that there is a single key that is present. I mean, the LWC engine doesn't need to evaluate if true and false in order to even display the div with a key. The key is always present. It just needs to find the relevant key and update the class, which means the re-render is much faster. So this is another small performance tip. So let me remove all of this. Now what I need to do is I need to make small changes. So right now my object is holding only snake, food and false, but then it also has to hold class, and I see it is snake. And there is one more optimization I can do. So if you remember, the game block is a class that I defined, and I need not always type game block here because it is redundant. So what I'm going to do is I'm going to modify the selector so that it is game container, and any div inside the game container of course is going to be our game block. So I'll just modify the div this way, and I'll say the class is snake. If not, the class is blank. Anything else that I need to do? I think that's it. Pretty simple fix for such a big problem. So let's save all. Wait for it to refresh. And it's gone. Basic snake didn't appear. Okay, let us inspect. Okay, I think the class snake has come into picture, but it is not getting applied because it's not important. Okay, hopefully now it should work. And yes, it showed, but it is not moving. Okay. Okay, that is because snake is false, which means the class becomes empty, and then the new position class becomes snake. Okay, so let's try if it works this way. So let's now go down. Okay, we are going down, and yep, if you notice, it's now much smoother. It's going up and immediately it is coming from the bottom instead of like there is a lag in very quickly getting incremented. So I think that issue is solved. So I think this is good. One thing I'm finding it very irritating is the numbers in between. So I'm just going to remove that and put a space there so that my game looks much nicer now. So now by the time that is refreshing, the next thing we need to do is we need to add food particles. So now, of course, if the snake is moving, not much of a game. It needs to have some food which it has to eat. So I'm going to now define a function called generate food. And now how is food generated in your snake games? Now typically your food is generated randomly, okay? Wherever you can place the food, you can place it randomly. So now how do you do random in JavaScript? It is using math.random. And what math.random does is it returns a value between 0 and 1. And you'll have to, based on that value between 0 and 1, you have to identify a particular coordinate. Now, since all of the coordinates are incremented by 1 and the maximum ends at the x max or y max, the easiest way to do it is to multiply the random value, which is a fractional value, to the final number, so that any number multiplied by a fraction is smaller than the number. Who knew maths would come in handy in computer science? So, so that way you get a number between 0 and the maximum value. That's exactly what we'll do. So let x coordinate of food is math.random into x max. So we give math.random into x max. It is again going to give us a fractional value. So we'll have to do math.floor again. I think that is it. Then let y of food is math.floor of math.random into this. Now you have generated the x and y coordinates for the food. How do you place it onto the canvas? Is using the game blocks. Let's remove the console log. Again, this statement comes in handy. So you say food position index is x.id is x food and y food. Now what we can do food is true, and then the class is food. Now what we need to do is we need to generate food. Again, on load itself, you add the keyboard controls, then you generate food, and then you start the game. So now let's save it, refresh. So there you go. Our food is present in that spot. It has gotten generated randomly. Now I move my snake to the food, and what happens? It eats the food and gone. So that's a happy implementation, because the moment it ate the food disappeared, primarily because we are setting the snake to true. But here is where it becomes easier for us to increment the score. So now every time the snake eats the food, we need the score to be incremented by 1. Which is why what we can do is we can just say in the new position index, you're going to get the element, and you say snake is equal to true, class is equal to snake. But then if the new position, I mean if the current position of the head of the snake dot food is true, then score plus plus, and initially the score must be 0, and which means now the score gets incremented. Now once the score gets incremented, what has to happen is food must be made false, and then you need to generate the new location of the food. So I'll again call this dot generate food. And once it eats the food, score must be 1, but it broke obviously because this dot score. Like I said, I make this mistake a lot. But at least it went into that block. I'm happy. So that's pretty much it. But aren't we missing something? I mean, the whole part of the snake game is every time the snake eats food, it has to become longer. So that is the core part. So once I eat the food, it went into a random location, and I play through it. The score is now 2. And so on and so forth. Basically, that's how it's going to work. But now is where it gets interesting. Every time the snake eats food, it has to become longer, which means other than the head, there is also supposed to be a tail to the snake, which gets incremented all the time. Now, how do you do that? Of course, you define a new array, of course, for the tail, because the tail can be of how much ever length it is. So using the tail as an array, you're going to hold all the coordinates of the tail. Now, when do you add elements to the tail is, okay, where was the food? Yep. So whenever it eats food, that is when its tail becomes longer. Now, in order to look at how tail and all works, I think it is again helpful to go back to the drawing board, because it's easier to explain it this way. Okay. So let's say these are our coordinates, and if we look at it in terms of numbers, it becomes easier. Okay, so now let's assume we have progressed in the game, because I think looking at it at a larger picture helps us understand the logic better. So let's say now the snake is of length 3 and we have the head present here. Now the first thing that we need to solve once we add a tail to the snake is incrementing all of the tail. I mean, right now if it was only the head, we just incremented the x and y coordinates of the head and it moved across the blocks. But if we have the tail as well, we need to increment all the elements of the tail so that the entire snake moves. So now what is the next position that this can be? Logically, if the snake is moving from left to right, the next logical position is 2, 3, 4 is the tail and 5 is the head. So so on and so forth. So what are we doing? We are incrementing head by 1, which we are already doing. But what we are doing is we are actually incrementing the tail as well. But it is not as simple as incrementing the value of each element, because the snake is always not moving in one direction. It can move in all the directions. So what you need to do is you need to shift the entire array. So in this case, what you'll notice is the difference between the row 1 and row 2. That means previous position and the current position is, in our tail array, which is highlighted in green, the first element is removed. And whatever is the current head, that has been added to the tail. So that is how the entire snake is moving. Now what happens if there is food at a particular place? So let's take the same example. We have the tail here, then we have the head at 4, and then we have food at 5. So what happens when the snake moves into 5? When snake moves into 5, it is the same. This tail becomes 2, 3, 4. And then the head and the food are in the same position. Right? That is when you are incrementing the score. But now what happens if the snake moves to 6? So if the snake moves to 6, obviously the tail length is 3. Because it has eaten the food, the tail has to increment by 1, which means the tail has to now become 4, which means the snake is still going to occupy all of this, and the head is going to be present here. So notice what has happened. So once it has eaten the food, I mean once you have incremented the score, now the tail array, which is 2, 3 and 4, has now become 2, 3, 4 and 5, which means after eating the food particle, the current head gets added to the array as well, to the tail array, after which automatically you are incrementing the head to the next value. But if it is not eating the food, the array length remains constant and the head just keeps incrementing, and the tail keeps removing the first element of the array and inserting the last element of the array. Now this is the business logic that goes behind moving the tail. Now let us write that logic. Now all of it is going to be in the move command. So in move, first things first, we need to, when it is moving, what is happening is we are removing the first element of the tails array. Now how do you remove? Okay, remove first element in array JavaScript. You're going to use the shift method to remove the first item from the array. So that is what we will do. I think that is what we will do. Yep. Okay, so move is this dot tail dot shift. So shift, as the documentation shows in VS Code, it removes the first element from an array and returns it. So now I'm shifting the element, so I get the first element. So let removed element is equal to tail dot shift. Now, what do I need to do with the removed element? I actually need to make the snake false, because once I remove one, it is no longer a part of the snake. So I need to make the snake false. So removed element is going to give me the index. So I'm going to use the same logic. Current position index. So removed element is going to be present here. Okay, so first let's do one thing. Let's add elements to the tail, because that makes my thought process easier. So once the score has been added, now I'm doing this dot tail dot push. Obviously we are adding a new element to the array. And what are we pushing? We are pushing the once it has eaten the food, we are actually pushing the current value. That means whatever is the current head is being pushed to the tail, which means we are going to push the new head into this one. Okay, so now removed element is tail.shift, which means you're getting the last element. So you're going to remove the equivalent of that and make the snake false. So if this is the logic, what happens if the head is 0? So you're going to push. Okay. The second one, if you go back to your drawing board, you'll see you're removing the first element, but you're also adding the current head value to the tail. So this was my existing tail. This is my existing head. First element from existing tail is removed. The current head is added, and then the head is incremented. Which means after removing the first element, I'm going to do this dot tail dot push of my current head, which is not my head, the snake's head, which is this. So it's better if we add, okay, let's keep it this way. So I'm removing the last element, then I'm pushing the element to the tail. Actually I need to push first and then remove the last element. So that way, even if the snake doesn't have any tail, I'm adding a new element to the tail and immediately removing the last element. If the tail size is 1, then first and last is going to get removed. And then this dot gameblocks.find index, I'm going to remove the element, all of that. Only the last element's tail is removed. Okay, but now there is one more logic here. So this should ideally move the snake. Let us check if it works. This logic is a little bit complicated, but nevertheless easier to grasp. Okay, so I am moving it. Then, okay, the snake has become longer, but something has happened. Okay, the snake is becoming longer, but if you notice, okay, I'll go back here and I'll show you. So the snake is becoming longer, but only after it crosses a certain point it is becoming longer. So let's see, the size is this. It is keeping the same size, but then it is then incrementing after some amount of time. Now, why is that? Now, that is because, okay, so whenever it is eating food, if you can see, the head and the food coincide, then I immediately add the head here. But then when it is trying to move to the next position, it's actually removing the first element according to our logic. It's actually removing 2 from our logic the next time it goes back. So what we have to do, every time it eats food and the tail length increases, we actually should not remove the first element of the array. Now, what is the condition for that is if the array is 2, 3, 4, 5 and the current head is also 5, then we are not supposed to remove it. because if you notice, the moment it comes to the next iteration, the head is 5, but the last element is also 5, then the head gets incremented to 6. So whenever the current head and the last position in the array is the same, we are not supposed to remove the first element. So obviously, now we have to get the last element. So last element, let last element is equal to this dot tail dot this dot tail of this dot tail dot length -1. So tail length is 5. So the fourth index is -1 is what I'm going to get. Now if the last element is not equal to x head and y head, then I am going to do all of this. Okay. If you're still confused by the logic, definitely go back to the drawing board and check why things are happening the way they are happening. It is helpful to draw it out, and definitely it's going to help you. Okay, so local development server load. Okay, so now my game, it is going that way. And then I eat the food. The length has incremented. Let me see if it still works nicely. Okay, the length is 3 immediately, and it's 4 and 5. Okay, it is good. But now the final part of it, how are you going to complete the game, is whenever the snake eats itself, the game should be complete. Now, how do you do that? So what does it mean when a snake eats itself? It means its head should actually come onto one of its tails. That means whenever you have incremented the head here, if your tail array, if this dot tail dot includes the current head, if this dot tail dot includes current head, that means game over, right? Which essentially means I make the tail empty, and then I say this dot x head is 0, this dot y head is 0 is what I do. If the tail includes the new head, yes. So pretty much that is about it. We'll test it once more, and then I'm going to show you how to deploy this to different orgs, to different instances, Heroku, GitHub Pages, and all of it. Okay, I mean, I love playing this game. Yep, the game is over once it has hit itself. And I think that is pretty much it. So I mean, there are more features that I'm going to add. I'll deploy this to the Salesforce or GitHub Pages and Heroku. And then I'm going to add more and more features to it. And then you can start playing it. Okay, so how do I first deploy it to Salesforce? I mean, I don't think that part I need to explain. All you need to do is ensure is exposed is true, and then I need to specify the targets. Okay, so targets app builder LWC. Okay, targets app page. LWC. And I generally like copy pasting stuff from here so that it becomes easier for me. Don't have to wait for the page to load. So I say app page and maybe the home page. So that is done. I'm already connected to a Scratch org. So I just need to open the terminal and I say sfdx for source push, and then it's going to get deployed. In the meanwhile, let me also open the default Scratch org so that I can drag and drop and show it to you. Okay, so it has deployed and the org has successfully ran. So let me open it up. Let me close the local development server. We no longer need it. Okay, so now I'm in my home page. So I want to add the game to the home page. So let me edit the page and then quickly drag and drop the component. Okay, so let me add it there. Okay, this is absolutely perfect. It's coming into this. Now let's say I drag and drop it into the smaller layout. Okay, you can see that the width has automatically adjusted and the game continues. So this is why I wanted to like give the width to be dynamic so that you can drag and drop it anywhere. And once you save and activate, the game is now deployed to Salesforce. Put it on your user's homepage, let them play around with it. Of course, like I mentioned, I'm going to add a little bit of more features like creating a button, and then if you click on start game, only then the snake starts to move and stuff like that. So let's assign it as an org default. And yep, so that's it about Salesforce. Now the next step is to deploy it to Heroku and GitHub Pages. Now both of these are external to Salesforce, which means you need to deploy them using the open source project. What I've done is I have pre-created the open source project. There is this npx create LWC app command that you use. And that is something that I have used to create this project. Now what I can do is I can go back to my app, the game, and then I can copy the game folder and come back here and paste it inside the my folder. Okay, so now the game has come here. I don't need the meta file. I'll just remove the meta file. And I don't need the standard greeting component. Let's remove that. I'm removing anything that is unnecessary. So app.css, I just need a container with 70 VW. Margin top is, let's say 10%. And then I have the app.html. Remove all of this, just give a div class is equal to container and write my game. So that's pretty much it. To see it in action, just run npm run watch. Then it's going to spin up again a local server. I mean, it's very similar to the local development server, but it's specific to the LWC OSS projects. Once it starts running, go to your localhost 3001 and hopefully you'll be able to see the game in action. Okay, here we go. The same app is working, my keyboard navigation controls are working, and as I move ahead, yep, the business logic is also working. It's just that I need to align this game to the center. So all I need to do is give margin 0 auto, and then yep, and yes, there you go. This is the final version of the app. And now I can deploy this to Heroku as well as GitHub Pages. Now, the first thing to do whenever you are deploying to GitHub, of course, to deploy to Heroku, I need not really deploy to GitHub, but I want to kill two birds with one stone. Now, this is one of the many ways in which you can do both of these things. So the first thing is I'm going to create a GitHub repository and deploy all of this code into the GitHub repo. And through the GitHub repo, you can enable GitHub Pages, and you can configure Heroku in such a way that any commits to the GitHub repo will automatically deploy to Heroku. So both of those things we will do. So the first things first, in order to deploy something to Heroku, you need to have a proc file in the root folder. So you say proc file, and then the contents of the proc file is going to be web:/npm run serve. I mean, if you want a more deeper dive on why all of these commands are written, we are going to roll out some quick takes pretty soon on this, so stay tuned. So the proc file is the only thing that is necessary to run this on Heroku. Now for GitHub Pages, the way it works is it either takes the content from a branch called as GH Pages, or it takes the content from a folder called docs. Now, how do you create that folder docs is whenever you build this project, I mean, whenever you run the build command for an LWC OSS project, by default, the final files are put into the dist folder, short for distribution. But now, instead of dist, we wanted to put it into the docs folder. So for that, let's actually open the LWC services config file and then go to what parameters this thing accepts. So if you see, the very first parameter it accepts is the build directory in case I want to configure it. So I use that, come back to my LWC services config file, put it inside the build directory, and I say it as docs. This also I change to docs. You also need to go to server.js and modify the distribution directory from .dist to docs. Let me now create a new GitHub repository for this. So let me click new repository, and I'll create it in my account, snake game LWC. Good that it is available. A public repository, I don't want to add a readme file or anything. I'll just create the repository. Now with this, I'll have to run a few commands, which are these, to initialize the empty repository. So git init, instead of adding just the readme file, I want to add all of my contents. So git add dot. So git commit first commit, and then git branch -m master. Okay, so what you'll notice is in case there are some linting errors, before you commit it to the database, it's going to throw those linting errors. So in my game.js, I have a linting error. Apparently, we have to use double equal to on line 1, triple equal to on line 130. And here I have to have the default value empty. I don't know, break. Okay, this should have this, and then of course the alert game over, disable no alert for this line, and line number 130 is triple equal to. Okay, so that's it, and we will try to recommit it. But before that, you remember we put this docs folder and all, but we never created that folder. So let's just run npm run build so that it actually runs a build and creates the docs folder for us. So right now, notice here, just node module script and src. In some time, you're going to get the docs folder. Yep, so here you go. The docs folder is created with the final files. And now we'll just add all of the files again. And this time we'll say first build. Let's see if the commit goes successfully. And it does. So our code is now committed. So the next one is branch -m master, then git remote add, and then git push u origin master. Okay, so now once I refresh this, all of my code is committed into the database. Now let's enable GitHub Pages for this. So for that, you just need to go to settings, scroll down to the GitHub Pages section, select your branch and select the docs folder and click save. So this is actually going to now create a deployment to GitHub Pages. It's going to take a minute or two. Before that, while that happens, we'll also try deploying it to Heroku. And once you've logged in, let's create a new app. Let's call it Snake Game LWC, and then create the app. Okay. So once I've created the app, the deployment method, I can just say connect to GitHub, and I'll connect it to the Snake Game LWC repo. So I'll just connect it. And once the connection is successful, I'll just say deploy branch. So this is one of the many ways in which I can do both the deployments in one shot. Like you can see, the build is beginning, and in some time this is going to be ready. But before that, let's go back to our Snake game, and let's see if the site is published or not. Yep, your site is published at so and so. So just click that. And here is our game live and working on GitHub Pages. So if you want, we can just play right away. Like I said, this looks very crude, but by the time you access it, like immediately after the session, I'm going to push some code to it to make it look more beautiful. But overall, this is what we built together during our live code session. And the same thing, we can wait for a minute or two by the time this completes, and the Heroku app will be live as well. I'm going to share the link to this GitHub repo with you on chat, and I'm also going to place this in the description if in case you're watching the recording. You can just go to this GitHub repo and look at the code, make a few changes, and every code that is pushed to this, as you can see, any code that is pushed to this repository automatically gets deployed to GitHub Pages, automatically gets deployed to Heroku. And you'll be able to find both of the environments on the right-hand side of the repo. So this is the repo. Here are the environments. So this is the Heroku app, and this is the GitHub Pages. Just click on them, and then you'll go to the relevant places. I'll also update the README file and all, so that it becomes more accessible. So that is what I've done. In case this happens, I'm going to show it to you. But if not, that is what you'll have to do. This is the CTA for all of you guys. Check out the GitHub repo, play, contribute, and of course, share it with everyone you know. Make them play, make them see. So Jerry from my team, he was telling like literally we can build anything on Salesforce, and never he imagined that we could build games also on Salesforce. So yeah, hope this session was entertaining at the least. I mean, informative. I hope you were able to take away some things like how to improve performance, when do you run into that infinite rendering loop and all of those, and how not to manipulate the DOM using JavaScript. There are definitely a lot more alternatives without you having to explicitly manipulate the DOM. So those are some of the key takeaways for today, as I would say. But definitely do play, contribute, and share. With that, thank you all of you for joining me today. Hopefully the Heroku app would have deployed by now, but yeah, definitely go and check out the GitHub repo for the links and then play on Heroku. So thank you all. Bye bye. Have a nice day.